Welcome to the channel. In this particular video, I will be explaining the problem maximum subset sum. Let's see the problem statement. So here is the problem. It says that given an array A of size n, find the maximum subset sum of elements that you can make from the given array such that for every two consecutive elements in the array, at least one of the element is present in our subset. What does this mean? Let me explain with the help of this example. So we are given an array 1, -1, 3 and 4. Now for this array, we have to choose a subset which is going to give the maximum sum, right? So there are multiple possibilities. We can choose 1 and -1, then we can choose 1 and 3, and then we can choose 4, right? And we can choose 1, -1 and 3. We can even choose 1 and 3 or -1 and 3. There are multiple possibilities, and the total possibilities are going to be 2 raised to the power n, because this is the number of subset that we have. Fine, but we are given one more condition, which is every two consecutive elements in the array, at least one of those elements should be present, right? Okay, so this means that when I talk about a subset which is 1 and 4, so let's say I have subset 1 and 4. So is this a valid? No, this is not a valid subset. Why? Because for this particular subset, we are not including any element from these two consecutive elements, right? So this is not something which can be tolerated. Now, what we can do is first of all, we can mark all the consecutive elements, like every two consecutive elements. So these are the first two consecutive element, these are the next two consecutive elements, and these are the last two consecutive elements, right? Fine. So from these consecutive element, we are going to pick at least one or two. So what we can do is we can choose this particular element, and then we can choose these three. So 1 and 3 is one of the possible sets, and we have even -1 and 4. So -1 and 4 is again one of the possible sets, and we can have -1 and 3 as well. So there are multiple possibilities, but one of the possibility is 1, 3 and 4. So if I choose 1, 3 and 4, then this is going to give me total sum as 8, and this is the maximum possible sum which is possible, right? So 8 is going to be the answer here. Now I hope you have understood the problem. So let me take one more example. Let's say I have the example 1, -1, -3 and 4. What could be the answer for this particular example? At first, it may come to your mind that 1 and 4, choosing 1 and 4 is going to give me the sum as 5, right? And 5 is going to be the output. But this is not correct. This is not correct. The reason is, in 1 and 4, we are ignoring these two elements, and these two are one of the two possible consecutive elements, right? So we have to include at least one from them. So in order to get the optimal answer, what we can do is we can include this particular element, and in this case I will have 1, -1 and +4. So this is going to give the answer as 4. Now let's talk about the solution. So in order to explain the solution, I have written the same example which is given in the problem statement. For this example, we can make some observations. So let me open the notepad here. Here I have written two important observations. So let's say I'm at particular index I. Now whether to include or not include this element, because for this problem, as we have to choose these subsets, so the first thing that comes to mind is, for every element we have two choices, right? Either we can take that element, or we can not take that element, and in this way we will have all the possibilities of choosing a subset from this particular array. Fine. Of course we have to ignore some of the cases where we have included like 1 and 4, so we have to keep like track of this as well, right? How we can do it? Let's say this is the previous element. So the first observation says that if we have not taken the previous element, then we must have to take the current element. Let me explain this. So let's say I have not taken this particular element, and I don't take this element as well. This way I'm not taking two consecutive elements, right? Like even one of the two consecutive elements. So you can see that this is something which is not a valid condition. Why? Because I have to take at least one from two consecutive elements. So this means that when I have not taken this element, then I must have to take the current element. Okay. And the second observation says that when we have taken the previous element, let's say I have taken this -1. In that case, I have two choices. I can either take this 3 or not take this 3. So this is what two observations means. Fine. So this means that I need to keep track of this particular thing as well, whether I have taken the previous element or not. In order to achieve this, I'm going to take a variable, and this variable will be a Boolean variable. Boolean variable. For the Boolean variable, we have either true or false. So when we have the value true, it means that we can have like we have included the last element, we have included the previous element, and we have when we have the value false, in that case we have not included the last element, right? So what I can do is now I can write the observation. But before that, let me write the function. Let's say I have a function, and this function is going to give me the solution from index I to n, right? So I have the index I and I have the n. But along with these two value like parameters, I have one more parameter which is previous. This is going to give me whether I have included the previous element or not. And one more parameter is the array itself, right? Fine. Now inside this, I can write my observation. So the first observation is if previous is equal to false. This means that I have not included the last element, right? So in that case, I must include this element, this particular element. There is no choice, right? So what I can do is I can simply return array of I plus solve for solve for I plus 1, and then what is the value of previous here? The value of previous will be true. Why true? Because I'm including the current element, and when I move like when I call the function again, then this value becomes the previous. And since I have included this value, so I need to write true here, and then I will write a and n, right? Okay, so there is one more condition which is else, and in else condition I have the value of previous as true. So whenever the value of previous is true, in that case I have two options. So I will write return first option is a of I plus solve for again the same thing I plus 1, then true, then a, and then n, right? And the second option is, okay, let me remove the semicolon. The second option is solve. Here I will not include the value, so I have two options, either take or not take for this. So if I not take, then I will have I plus 1, and not taking means the value of previous as false, and then I have a and n, right? Okay, now I need to return the maximum of these two values. Why maximum? Because you can see that I have to find the maximum subset sum, right? So whatever the value these two possibility give me, I have to consider the maximum of those two. Fine. Now this is the whole thing that I need to do. And you can see one more thing, that since it is a recursive function, it is calling itself here and here as well, right? So this function must have a base condition, and as we are increasing the value of I and I again, so there is one point where I should stop. So that point is going to be I is equal to n, because whenever we have I equals to n, then a of I is not possible. So in that case I have to return 0. This is how we can solve this problem. And at last this is the main function, right? So we need to call this function. And how we can call this function? We can simply write this line. This line basically means that when I'm at starting position, then I should have choice whether to include this element or not, right? So in that case, the value of previous should be true, because only for previous value true, we have two choices. So I want two choices for the starting element. So this is how we can call the function, right? Okay. Now the problem with this approach is this is going to work fine, but this is not going to work for large inputs. What is the reason? What is the reason? The reason is quite simple, that this is a recursive function which is going to try out all the possibilities in a brute force manner, right? So what is the complexity? Since for every possible value we have two choices. Of course, we have some condition where I have only one choice, but what we are going to consider the worst case here. So in the worst case, we can have the complexity of 2 raised to the power n, right? So this is the complexity for recursive approach. And now let me show you the recursive tree for this particular example. For this example, here is the recursive tree, and for the recursive tree I have the initial value of I in previous here, and the initial value comes from this function call. You can see that I have 0 and true, right? And from the initial value, when the index of I is 0, then you can see that I have two options. I can either take or not take. So when I take, then I have again the value as 1 and true, because I have taken the last value, and the value 1 will be added here, right? And when I don't take, then I have 1 and false here, right? And in case of false, I have only one choice, you can see here. And in case of true, we have two choices. You can even notice this thing from here, right? Okay, so this is how we can write the recursive tree for this. And in this recursive tree, I want you to notice two important things. The first is optimal substructure. Optimal substructure, okay, let me write the spelling. So struct. Okay, so this is the spelling, right? And now the second thing that we can observe is this particular thing. You can see that I have the 3 and true here, and I have the same thing here as well. I have even the same thing here as well. And you can see that 3 false is here, and again the same thing is here, and you can see that same thing I have written here. This means that I am solving same problem again and again. So my question is, if I have already solved the same problem for like this particular case, then why to solve the same sub problem for this and this case? This is the question, right? We can avoid solving this problem, and in this way we can optimize the time complexity. So what I can do is I can observe one more thing, which is overlapping subproblems. So these are the two important observation, and whenever we have these two conditions satisfied, then we can apply something which is called dynamic programming. So let me write dynamic programming here. Okay, so as we have already observed the like overlapping subproblems, so what we can do is we can make a DP array. DP array basically means dynamic programming array. What could be the size? The size is basically n plus 1 and 2. This is the size. Why? Because every time I need to store a subproblem which is dependent of on two variables, which is I and previous. So I will store something like dp of I and previous is equal to previous is equal to any solution, like let's say solution for any particular subproblem, right? So this is how we can solve the like we can store the subproblems. So now as we are talking about storing subproblems, so you can see that I have I here. This means that the maximum number of row can be 0 to n plus 1. And similarly we have previous here. So for previous we have only two possibilities, either 0 or 1. So that's why I have taken the size 2 for column, right? So now what I can do is I can write, okay, so I can make a DP array of n plus 1 and 2, and in this DP array every time I need to store DP of I and previous is basically going to be the solution of that particular subproblem. And whenever I have the solution, then I need to check whether I have already solved the problem or not. And if I have solved the problem, let's say for this problem I have already solved it, right? So I don't need to solve it again. Instead I can simply write that particular value. So what I'll write is, if dp of I and previous is not equal to null. But before this, when I'm checking this null value, so I need to initialize this dp array with null. So initialize with null, right? Okay, so once I have initialized with null, then I can simply check a null value, and after this I can simply return dp of I and previous. This means that if the problem is already solved, only in that case I will not have null value here, right? And I can simply return that particular value in that case. So this is something which is called as memoization approach. So let me write this. This is something which is memoization approach. Now, when I apply this approach, then the time complexity will reduce to O of n. N cross 2 actually, but it is similar to again O of n. Why time complexity has reduced? You can see that every time we can have at most n plus 1 cross 2 subproblems, right? And whenever we have these subproblems, so we can return the value like this. So this way we can optimize the time complexity, right? Fine. So now let me show you the code. Let me show you the code. Okay, so here I have written the Java code, and here I have the C++ and Python code, right? And you can see that I have the recursive function here. Then on the same recursive function, I'm applying the dynamic programming using memoization approach. So this is the main line which is going to call the like once we have already solved the problem, so it is going to check whether we have already solved or not, and then it is going to take step accordingly, right? Now If previous taken is equal to 0, 0 means false. In that case, I need to do this, else I need to do this. I have two choices for this, right? Fine. So this is how I am calling the function. Now, you can see that the code is same for C++ as well. And let me show you the Python code. So this is the Python code. The problem with Python code is this code is not going to work because there is a recursion limit on like in Python, right? And if you increase the limit, still it is going to give you segmentation fault for a particular test case. Now you can see that when you don't you will observe one thing. When you don't call this particular function, then your code is going to fail for 17th test case. And when you call this function, then your code will work till the 1111th test case, right? So but still it is not going to work fine because we have total 1115 test cases. Okay, fine. So now we can optimize this. You can see that this time our solution is something which is relying on the recursion stack, right? So we can write a solution which is independent of the recursion stack. Interestingly, we already have one approach for this, and that approach is called known as the tabulation approach. So let me write the heading, which is tabulation. Tabulation approach is also known as bottom-up programming, dynamic programming, and for this we start from the base case and then we move towards the solution. So for this we need to understand some things. We have the DP array and the structure is going to remain same like this. Fine. So now you can see that DP of I0 is basically representing not take the current value, right? And DP of I1 is representing take the current value. Fine. So now you can see that what is the base case here? The base case is basically n, right? When I is equal to n, then the answer is 0. So I need to start from the base case. This is how bottom-up dynamic programming works. So I'll write 0 and 0 for this. Why? Because doesn't matter whether I take or not take. For I equals to n, the answer is going to be 0. And what is the, okay, so I have not written one thing here, that array. So array is 1, -1, 3 and 4. For this array, the size of array is 4, right? And when I say n plus 1, then I have 1 2 3 4 5 as the size. So at this I is equal to n, so the answer is 0, right? Fine. Now one more thing is, so I can so first of all I can make the DP array, and DP array is going to have sizes n plus 1 and 2. Okay, and I can start with the base condition. I will write DP of n, and 0 is going to be a 0, and DP of n and 1 is something which is going to be 1, right? Fine. You can see one more thing that whenever we have the previous value false, which is equal to 0 for that particular case, so whenever we have previous value false, in that case we don't have any choice, we have to include the current value, right? So now every index I here is going to represent the previous value. This is very important. Why previous value? Because you can see that we have already solved the solution for like we have already solved for the next value. So next value will act as the current value, and this will act as the previous value. So every I is basically the previous value. Fine, you need to understand this thing. Now whenever we have not taken the previous value, so 0 basically means not take the previous value. So in that case I must take the next value, right? So this for this particular part the answer is going to be 0. I hope you are able to understand this. Fine. So what I'll do is I will write one thing, that dp of I and 0. DP of I and 0 basically means that if I don't take the current value, if I don't take the ith value is basically the previous value. So if I don't take the previous value, then I must have to take the next value. And take next value simply means that I plus 1 and 1. So DP of I plus 1 and 1. I know this is a bit tricky to understand, but as I move further, then you will be able to get the solution, right? Okay, so now what about this particular case? When I take the current value, in that case, how I can take the current value? I can simply add the current array value, and after this, I can take the maximum of these two. This is what we do. You can see that if you take the previous value, then we do something like taking the maximum, right? So I'll do something like dp of I1, dp of I and 1, which means that I'm taking the previous value. This I basically means previous value. In that case, my answer will be max of I plus 1 and 0, and okay, dp of I plus 1 and 0, and then dp of I plus 1 and 1, right? I need to take the max of this, and then I need to add the current value. Why add current value? Because I'm taking the previous value, right? So this is how we can get here at this position. What is the array? The array is basically this particular value, right? And I'm at this index, so for this index I can simply add 4 here, right? And maximum of this is going to be to, like 0 again, so 4 plus 0 is again going to be 4, right? Fine. Okay, let me move this thing a bit upwards, so that, okay, even I can do one thing, that I can write the array below. So the array is 1 minus 1 3 and 4, right? Fine. I have processed for this. Now I come to this point. For this point, again dp of I0 will be this 4, and dp of I1 will be 3 plus maximum of these two, which is 4. So this is going to be 3 plus 4, which is 7, right? Now I come to this point. And for this point, dp of I0 is again going to be this 7, and dp of I1 is going to be maximum of these two, which is 7 plus the current value, which is going to be 6, right? Fine. Now I come to this point. For this point, dp of I0 is going to be 6, and dp of I1 is going to be maximum of these two plus current value, which is 1. So it will be 1 plus 7, which is 8. So 8 is going to be the output for this particular array. Fine. So what I'm doing is I'm performing the function for every possible like index, right? And I have derived the solution from this particular recursive code only. I have not taken anything which is out of the concept. So what I can do is I can simply do one thing, that for I equals to n minus 1 and I is greater than equal to 0 and I minus minus, I have to do this thing, right? Fine. Once I have done this thing, then you can see that the main answer is going to be maximum of these two values. I can either take the first value, okay, I can either take the first value or not take the first value. So at last I need to return one thing, that solution is going to be max of dp of 0 and 0 or dp of 0 and 1. This is how we can solve the problem using the tabulation approach. And now you can see that as I'm using a 2D vector, so the solution is independent of the recursive stack here. Fine. So let me, okay, complexity is going to remain same, O of n for the time complexity and O of n for the space complexity. Now let me show you the code. Okay, so here is the code. Java tabulation code is written here. You can see that the code is very similar to the one I have already explained. And you can see that C++ code is here, and this is the Python code. So I hope you have understood the problem well and the solution and the intuition behind the solution. So this is all about this video. Thank you.